Calculating quantities calculations. These are some of the most interesting and widely used in chemistry, if your desires to study A-level chemistry or beyond, or indeed just do well at GCSE, you have to master these. Now, there's a couple of ways of doing these. For high-level chemists or chemists that want to go study A-level, then I much prefer to teach the method I'm about to show you. However, there is a different method to do it, and if you're a foundation level student or you just want to get these questions done, then there is another way to do this, and maybe I'll show that in a future video, but I'm going to show the way that's best for high-level chemistry right now. So the question is, we have the electrolysis of aluminium oxide, and that splits aluminium oxide into aluminium and oxygen. The question says, calculate the maximum mass of aluminium. So first off, start labelling the equation. That's my advice to you. Calculate the maximum mass of aluminium. That's the question mark. That's what we're trying to find out. That can be obtained from 510 tonnes of aluminium oxide. Let's write the 510 under there. Now, don't worry too much about it being a tonne. Okay, the thing with these questions, whatever unit of mass we start with, that has to be the unit of the mass at the end. So straight away, I'm just going to write the word tonnes down here. Okay. Because that's where we're going to report the answer at the end. The unit at the start becomes the unit at the end. So we're not going to worry about the unit. Okay, so this is what we're going to do here is a mole calculation. This is for solids. Okay, so we need the moles equation for solids, and that will be moles equals mass over the mass of 1 mole. Okay, now with all moles calculations, there are always 3 distinct stages. The first stage is going to be moles, calculate the moles. In this case, it will be of the aluminium oxide. The next stage will be stoichiometry. Okay, stoichiometry is the word that we use to look at the reacting ratios in the equation. And we can see in this equation here that 2 moles of aluminium oxide react, and when they're electrolyzed, when they react, they make 4 moles of aluminium. So stoichiometry is a relationship between these numbers. So we're going to be looking in the next stage at these 2 numbers here. And the final stage will be moles again, because when we've done that, the first thing we're going to do is calculate the number of moles of that. In stoichiometry, we're going to work out how many moles of the aluminium are produced. But the question doesn't ask us for moles, it asks us for tonnes. So the final stage has got to be taking the moles of aluminium and making it back into a mass. So moles, stoichiometry, moles. Every moles calculation has those 3 distinct stages. So this first one, moles. The first thing we're going to have to do is write down the moles equation. As I just said, moles equals mass over the mass of 1 mole. I'm just going to abbreviate that phrase, mass of 1 mole, into MR, the formula mass. That's just an abbreviation some chemists use. So I'm just going to do that just to make it quick and easy to write. And I'll put a box around that because that's so important. So the first thing we're going to have to do before we can do this is calculate the formula mass, the mass of 1 mole. The mass of 1 mole of aluminium oxide. Okay, so let's write Al2O3 over here. So we're going to calculate that MR. That's the first thing we're going to do, calculate the MR of aluminium oxide. Al2O3. So what we can see here is we've got 2 aluminiums and 3 oxygens. 1 aluminium weighs 27, but we don't have 1, we have 2, so plus 27. O3, 1 oxygen weighs 16, we don't have 1, we have 3, so we need to write plus 16, plus 16, plus 16. Add all that together, 27 plus 27 plus 16 plus 16 plus 16 equals 102, equals 102. So moles equals mass over the mass of 1 mole. The mass in the question was 510. So let's write that there. 510 divided by the formula mass, the mass of 1 mole, 102. 102. 510 divided by 102, that looks like it's 5 to me. Divided by 102 equals 5. Equals 5 moles. Okay, you get that far in the exam, you probably get a mark for writing. You got 5 moles of aluminium oxide. You're showing you're working. This is good. It's good stuff. Right, stoichiometry. Let's write the parts of the equation we need down here. 2Al2O3 make 4Al. We could write the plus O2 down the end, but we don't need it. It's not part of this question. So, you could even cross it out up here if you want to. It's just not part of the question. This tells us 2 moles of aluminium oxide make 4 moles of aluminium. That's a stoichiometry, 2 to 4. That's a doubling relationship. 2 doubled is 4. Okay, now we don't start with 2 moles, we start with 5 moles. Okay, looking at stoichiometry, a doubling relationship. 2 doubled is 4, 5 doubled is 10. 10 moles of aluminium. Okay, that's the second stage done. So we've done the first bit, moles, we've now done stoichiometry. In the first bit we calculated the number of moles of aluminium oxide. In the second bit we've said, okay, in this equation, 2 moles of aluminium oxide make 4 moles of aluminium, so we need to double that, 5 moles to make 10 moles. The third stage, we've now got 10 moles of aluminium. So we're coming back to this moles calculation again. Moles equals mass over mR that we boxed off here. Okay, we don't want moles equals now, we want mass equals, because we need to give the answer as tons. So mass equals, so we need to rearrange this equation. Mass equals moles times mR. Okay, you can either learn that or you can learn how to rearrange the equation. If it helps, I will stick a formula triangle here. Moles is going to go down there, the multiplied, mR down there, and mass down there, at the top there. And you can use that and just learn that. We want mass as a subject here, put your finger over mass, it tells you it's moles times mR. If we want moles, it's mole, put your finger over moles, it's moles equals mass divided by mR. So the moles, we've worked that out, that's there, 10. Aluminium is just the mass of the atom here, isn't it? Because the formula is Al on its own, so it's the relative atomic mass. There it is there, 27. 10 times 27, and that's going to be equal 270. And there's our answer, 270 tons. Again, these are fairly standard exam questions, and so here's a good example of what the exam might look like. As I said, there are easier ways to do these, and the exam mark scheme will probably show the easier way, if I'm honest. But if you can do this, then other mole calculations are going to be so much easier. If you do it this way, certainly the other mole calculations will be so much easier. Right, so let's look at this question. Sodium reacts with chlorine to form sodium chloride. Calculate the maximum mass of sodium chloride. Well, there's a sodium chloride, question mark underneath it, just like we did a moment ago. We label everything up. Maximum sodium chloride that could be formed by reacting 9.10 grams of sodium. 9.10 grams of sodium. Sorry, 9.2 grams of sodium with excess chlorine. Well, it's excess chlorine. Excess means too much. It means we can cross it out, basically. By using excess, we just ensure all the sodium reacts. So the reaction is dependent on the sodium, not the chlorine. But for practical purposes, it means we can cross the chlorine out. So moles, stoichiometry, moles. First off then, moles equals mass over the mass of 1 mole. Okay, we're starting here with sodium, so I'll put AR down there because that's a nice abbreviation for relative atomic mass. Mass, we've said is 9.2. Okay, the atomic mass of chlorine, sorry, atomic mass of sodium, we're given the mass of sodium, atomic mass of sodium is 23. 23. Okay, let's put those into the calculator. 9.2 divided by 23 equals 0.4. We've got 0.4 of a mole of sodium. So that's the moles. Next stage, stoichiometry. Look at the reaction. Look at the reaction ratio. Let's write out the parts of the equation we need. 2Na. Cross the chlorine out, didn't we? 2Na make 2NaCl. Okay. So these numbers here, 2 moles of sodium make 2 moles of sodium chloride. These numbers are the same. This, therefore, is the same relationship, or a one-to-one relationship. So if we start with 2 moles of sodium, we end up with 2 moles of sodium chloride. We don't start with 2 moles of sodium. We start with 0.4 of a mole of sodium. And therefore, we are going to make 0.4 of a mole of sodium chloride. Okay, so moles, stoichiometry, final stage now, moles. But we need to rearrange the equation, remember. Mass equals moles times the formula mass, the mass of 1 mole. In this case, it's of the question mark. So before we can do this, we need to work out the formula mass of the sodium chloride. So NaCl, let's do that here. NaCl. That's got 1 sodium in it. There's no number after the sodium, so it's a 1. It's got 1 chlorine in it. So we just need the atomic mass of sodium and chlorine, and we need to add them together. So 23 plus 35.5. Looks like 58.5 to me. Let's put it in the calculator just to check it. So we have 23 plus 35.5 equals 58.5. So we now have the mass of 1 mole. Let's put that in there, 58.5, multiplied by the number of moles of sodium chloride. We work that out here in stoichiometry, 0.4. Okay, so let's multiply those two together. And we get the answer 23.4, and we started with grams, so we must finish with grams, and indeed the unit is given down there. 23.4 is our answer.